My name is Nancy Roberts. I'm an economics professor at Arizona State University. And today I want to work a problem about using Coke and Pepsi as an example to measure cross-price elasticity. We're going to have the price of Pepsi increase, and we're going to see what happens to the demand for Coke as a result of the increase in the price of Pepsi. So what I have already written up here on the board is the way we measure cross-price elasticity. It measures the percentage change in the demand for some good, in this case Coke, when there's a certain percentage change in the price of a related good, in this case Pepsi. And again, we're going to use the midpoint formula. When we ask how much does demand change and how much does price change, we're using the midpoint of the two prices. We're using the midpoint of the two changes in demand. And so our formula actually reduces to this. So if the price of Pepsi goes up from 50 cents to $1, what we know happens in the Pepsi market is that quantity demanded decreases from Q1 to Q2. We know that. Now, the question is, what are all these people who used to drink Pepsi going to do? Are they going to give up soda pop? No. Some of them are going to come over here and join the Coke market. So the demand for Coke is going to increase. And so let's just have a new demand curve like that. And again, whatever the price is, it doesn't matter what the original price of Coke is. If it was higher or lower than either of these prices is irrelevant. What matters is that Coke now is relatively cheaper to Pepsi than it was before this price increased. And so now the question is, at this price, whatever the price was, the demand for Coke is going to increase from 15 to, let's just say, 25 units per time period. So now we have all the ingredients to measure cross-price elasticity. And once we measure cross-price elasticity, we want to interpret what we found. And so let's just plug our numbers in. PY1 plus PY2 over 2 is going to be 75 cents. That's this. And D1 plus D2 over 2 is going to be 20. The change in demand is going to be 10. The change in price is 50 cents. And so our calculation turns out to be, our cross-price elasticity calculation turns out to be 0.75. And so how do we interpret this? This says that the percentage change in the demand for X that comes about because of a percentage change in the price of Y, how much does demand for Coke increase when price increases by this percentage, is 0.75. How do we interpret that? 0.75 is the same thing as 0.75 over 1. So a 1% change in the price of Pepsi will lead to a 0.75% change in the demand for Coke. So you increase the price of Pepsi this much, you're going to get this much of a change in the demand for Coke. If the goods are substitutes, this is always going to be a positive number. The more positive the number is, the closer they are to substitutes. If this number, instead of being 0.75, had been 75, then it would say increase the price of this by 1%, and you're going to get a 75% increase in the demand. That would mean these things are almost identical. If this number is very, very close to 0, very, very close, 0.00009, 0.00009. What does that say? that says that if you increase the price of one good by 1%, the demand for the other one is like gonna blink, and that's it. That'd be like saying, well, if you raise the price of a can of spinach, what's that gonna do to the demand for dog licenses? It's like nothing, because they're unrelated. So the higher the number, the closer they are as substitutes. The closer to zero the number gets, the more unrelated they are. And if these were complements, like we talked about tennis balls and tennis rackets, the number would actually be a negative number. And in fact, we'll have a problem in the next video showing how what the cross-price elasticity looks like for complements.